behalf of KIET Group of institutions and all the dignitaries who are present here, I request Dr. C.H. Bhavan Narayana sir, the KIET Plus principal, to come onto the dais and honor our respected guest Dr. Anil Kumar Uppala with a bouquet. Sir, I request Dr. Anil Kumar sir to come onto the dais.
So far I heard that Godavari districts are known for hospitality. Today I was overwhelmed by seeing your response. Can you hear me? Yeah. Thank you so much for grand welcome. Okay, I never expected this. And once again, thank you for your management to invite me here, and mainly Ravikant and other faculty. Madam, of course, she visited IIIT. You are all third year? Yeah. Okay, good. How many of you have smart TV at your home? Smart TV, yeah. So, have you seen the microphone button there in the remote? Okay, what it does? Huh? Voice input. So, how many of you have smart mobile? Wrong question to ask, right? So all of you might be experiencing okay Google, right? So you want to know how? Majorly we are working in this area that speech analysis, basically speech processing. So especially our interest is in Indian languages. You might have seen Alexa or okay Google, etc. work very well for English, isn't it? They do work for Indian languages, right? But there is much more thing to be done. Okay, so one of my big project recently completed one is we collected 2,000 hours of Telugu data. Okay, that is transcribed data. A lot of audio data is already available in the form of YouTube, etc. But to build such a system of speech recognition, we need huge amounts of data, which covers from different accents and different speakers, right? So it's around 1.2 crore worth project actually. So we recently completed. Just let me start the session with that demo. This is actually first, we are fortunate that, it is the first Indian language where we got this much amount of data. Now other major Indian language also we are collecting the data, but Telugu we already have this 2,000 hours of data, which will be very helpful to build the speech recognition. So this is our website, asr.iit. You can also try in your mobile. Okay, asr.iit.ac.in. So in that you have to go to option called test with voice. So if you go with asr.iit.ac.in, it will come. It's asr.iit.ac.in voice.test. We have different speech recognition systems. So this is our project outcome. So I can speak in Telugu here, and it will play. It will get recognized. So I'm just. You have to touch this microphone. You will get a cross button. Then you have to speak. నేను తెలుగులో మాట్లాడుతున్నాను. ఇక్కడ వచ్చిన వాళ్ళందరికీ మేము ఏం చేస్తామో చెప్తున్నాం. నేను తెలుగులో మాట్లాడుతున్నాను. ఇక్కడ వచ్చిన వాళ్ళందరికీ మేము ఏం చేస్తామో చెప్తున్నాం. So that is the outcome. So you can see almost correct, except maybe last but one word, right? Yeah. So this is a generic ASR. Now we are also working with the domain specific ASR. Okay. So which can work in medical domain, education domain, etc. I will tell you why we need 2,000 hours of data. What is the AI behind this? That's what we'll discuss. How many of you have seen the speech signal so far? Okay. So this is how speech signal look like. Okay, not the top one. Top one is anyway pitch contour. Okay, this is how speech signal look like. Okay. So next question to all of you is that why we need speech processing to be done? What is the goal? Why we need this speech processing? Why we need speech processing? Already text processing is there, right? NLP. Okay, why we need speech processing? Optimizing the in what way? Yeah, he's saying that rather than typing, right, it is easy to speak. Not only that, it is easy maybe for you to speak, but you go to your parents or grandparents, they don't know how to type. They don't know how to type, right? But they know how to speak. At least their mother tongue, they know how to speak. So the disadvantage of NLP is that it will be useful only for the educated people. Okay, let us say you gifted iPhone to your grandparents who are not well educated. What they will do, even if you give feature phone or iPhone, it is okay. Same for them. They don't know other than green button, red button. But activate Siri and give. Have you heard about Siri? Activate Siri and give. Okay. Then they may talk with the phone and the phone may operate. They may operate phone with the speech, because the power of speech is our natural mode of communication. Okay, speech is our natural mode of communication. God has gifted that. How you will communicate with others? Speech, right? So if you develop, the main goal of this speech processing is that whatever the way I am talking to my friend, can I talk with the machine? That is the goal. Can I talk with a machine? That is the goal of this speech processing. Okay, so when I talk something, I just say I am from Hyderabad. I just said I am from Hyderabad. Okay. Anyway, I am from Vijayawada, not from Hyderabad. Okay, I am okay. Let us say I said one sentence. What your human brain is saying, telling to you, what information you are gaining? You got the message, some message. I am conveying some message, my place or something. You got that. What else you got? That message, that is under message. You got the message, and you may know, if you know me as Anil, you know that, because everybody's speech is different. Even if I say out of the wall, let us say I said behind the wall. Let us say I am there behind the wall. If you know me already, I say I am from Hyderabad. From my voice you can recognize me, right? So you know my speaker and you know the message. What else is there? Language, right? Excellent. We have a language. So I am speaking in English. Okay. What else? What else? Whether I am speaking happily or neutrally or angrily, you can say I can shout, or I can emotion. Anything else? Gender, my age, roughly age, or speaker related information, age, gender, accent. Based on my accent, you may say I am from which place, etc. Right? So all that information your human brain is understanding. We want machine to do that. Okay. If you do, if you get a message, so these are all information embedded in the speech. So if you have one speech signal with you, it has a message, it has the language, gender, age, speaker identity, emotional state, or if you have any difficulties in the speech production, if somebody has some speech production problems, all that information is within a fraction of a second your brain is telling, right? So we want machine to do that, so that the way you are understanding the message, machine also will understand. So how many of you have seen Alexa or OK Google in the cars? Nowadays you have car is activated. The current cars are coming with this kind of application, right? So many more to come. Smart appliances in your home, not only smartphone and remote. Many more will come in future. So the main goal is that to reach the lower pyramid. So speech will be the modality. So we should not expect text anymore. Okay, you should expect speech. Okay, through speech your device should operate. Through speech your action should happen, so that it will be, as you said, more convenient and also more usable, because text is only, it's not exaggeration, not more than 20 to 30% of our Indian population know how to type, not even their mother tongue. 60 to 70% of the people, they don't even know how to write even their own language. Okay, so how see lot of information is there in the internet. All of you agree? Lot of information. What yeah, I think nowadays I get a laugh when somebody asks something, because why you have to ask something? Now in this current world, if you have internet, you should not say no, because you ask anything in the internet, it will tell you. Right? I don't have information that answer is not valid in this IT world, right? So similarly, but still a lot of people are with lack of information doing something, right? Their information is not reaching to the needy people. Let us say weather information, or some commodity price information, or some information is not reaching to the farmers or the needy people actually. Okay, because they don't know how to access this IT, right? So, but if you activate, if you just speak and get the information, that will reach more. Okay, that is a main motivation for speech processing. And a good part in India is that we have so many languages. So let's say country with like China or something, few languages only. They have one or two languages. But in a country like India, how many official languages we have? How many? 22. And if you include Indian English, 23. We have 23 official languages. So much work to be done. And we have our own complexities. Our language are our own complexities. I will tell few of them little later. So a lot of work need to be done. Yeah. So as I said, the goal of speech processing is to make human-computer interaction as natural as possible. So these are all technologies. If I get a information from speech, so whatever this Alexa or OK Google are doing, that is called speech recognition. What is called? Speech recognition. Speech to text conversion. Okay. And when communication completes, communication will complete if system understand your thing and also respond. You can ask right now, hey Alexa, what is the weather in Hyderabad? You have now device coming, right? Or hey Alexa, play some song for me. You can ask in the car, right? So it will play, I am playing so and so song for you. It will say, right? That technology is called text to speech. Okay, two technologies are more important, ASR and TTS. ASR means automatic speech recognition, that is speech to text conversion. Other one is text to speech. Okay, these two are the basic systems. Already you are experiencing with with this monopolies like Google and you see Microsoft and like Amazon. So now the goal is that, so what is happening, if you want to build any speech application, unfortunately you have to use the APIs of these giants actually. On the other hand, Indian government now took the initiation, and they had start recently. Prime Minister is also very much interested to launch this mission called Natural Language Mission Translation Mission. It is also called Bhashini. If you are interested, you just check in the internet, Bhashini. Okay, you should all check in the Bhashini, because in that very soon all text databases, speech databases will be hosted there. Anybody want to, people like you want to develop some product or something, you should use that technology, because otherwise all we are end up in like taking the Google API and Microsoft API and that's it, and all our data is going to them freely. Okay, instead we can build our own application, in-house applications. Okay, so with that motivation, so to start with, luckily we have already collected Telugu data, a lot of data, and we hosted already there. So similarly, many other language data is going there actually. So along with that, speaker recognition, that means take input as speech and identify the speaker. You might have all seen, right? How many of you seen Shivaji movie? Maybe old for you, but maybe okay for our generation, because maybe you people are 10 years younger than us. So, but still you might have seen a Shivaji movie, right? You might have seen the password cracking in the laptop. You can put the voice-based passwords because everybody's speech is unique, right? Similarly, we can also identify the language. How many of you called to call center? How many of your parents asked you to call center? They might have asked because they don't know how to call center. Because it will ask press 1 for Telugu, press 2 for English, press 3. Why I have to press? I am speaking, you should understand. Current future technology is that. Future technology is that no need to press any 1, 2, because the moment you ask press 1 something, I know many people don't know how to press. It may look simple for you, but it may be more complex for others. They will be afraid, if I press 1, what will happen? There something, it's not easy. So the speech is the way to go. Okay. And similarly, I have got my one of first project in 2014 is on language identification. So we collected all 23 languages, around 50 speakers of data, and build that language identification system actually. So very soon they will come as a products. So similarly, we can also use pronunciation evaluation tools. And recently, as my core interest is along the signal processing and AI, not only AI, so we started a lot of work in the space of speech pathology. Okay, many population have problems like dysarthria, stuttering, right, dementia, or hypernasality. There are some voice disorders. May not be initially, but through age, so after stroke or after something, speech problems will come. So we are now analyzing how to develop a tool which will help to the patients, so to get a feedback. Let's say they are picking up the something, can we design a software for them to give a automatic feedback, or first of all can we recognize the problem with the level of severity? All that we are doing actually. We have a collaboration with something institute called All India Institute of Speech and Hearing, Mysore. Okay, they will provide the data for us, and we are building the systems actually. So these are the areas. These are all comes under speech processing umbrella. So automatic speech recognition, text to speech, speaker recognition, emotion recognition, right? Emotion recognition, language identification, pathological speech recognition. All these are the problems. So far I already guided 5 PhD students. They are graduated, and another 6 students are working with me for full-time PhD. They're all working in the different aspects of these problems. So yeah, just to emphasize, so you already understand now by now, right, what is the power of speech application, right? What is the power of speech? If you develop a speech application, the reach will be more. But now next 5-10 minutes we'll see what is the issue in building that. Why not people have taken, why Alexa has come now couple of years back. Our chairman is Professor Raj Reddy. You might have heard his name. Have you heard his name, Professor Raj Reddy? He is a very well-known figure in US. So I think he also the one who started this AP IIITs, etc. So initiated with Chandrababu Naidu time. That time he started our IIIT. So it's our 25th year. So now from last 25 years he is the chairman. Now he is stepping down actually. But why I'm mentioning that, he is the first Stanford PhD in 1964, I guess, 64 or 67. First Stanford PhD in computer science. His PhD is on ASR. His PhD is on speech recognition. So see the dream of 1960, and he came, and I met him a couple of years back. He was overwhelmed by seeing the product like Alexa, which they dreamed. Lucky that he is still alive because he's 80 plus, 85, I think, 87 or 85. Still he is very active. I saw a couple of days back he is walking in our campus. He came from US. He felt very happy because it's his dream. His dream somewhere around 60-65 years back. Dream that speech recognition application has come, right? So you may think that why it took that many years. What is the problem? The problem is because speech is not an easy signal to handle. It has a lot of variations. Human brain is very powerful to understand the things, right? On a lighter note, if I am telling something, if you really want to listen to your friend, you can suppress my speech and talk to your friend, right? Even within the class, right? And so our human brain will fill a lot of things actually. Let's say if I miss something also, you will fill it up because you have your brain has that capacity. All that knowledge transferring to the machine is not easy. That is one part. Second part is, speech is not a structure, not a proper input like text. For example, I call 10 people to come and type here, I am from Hyderabad. The sentence I am from Hyderabad, I ask 10 people to come and type here. Everybody will type same, na? But the same thing I will ask 10 people to speak here. I will record your speech and speak here. I will record your speech, it will come the way I shown the speech signal, right? It will come like this. You see that signal, you ask 11th person and ask that is this 10 sentence same or not? 99% he says they are not same. But if you play, that is same. The information is same. System has to understand. See, because I am from Hyderabad, if 10 people are speaking, their accent is different, may be different. Their way of speaking is different. Their pitch is different. All that variations will come. On a lighter note, we can compare speeches like a cursive writing. How many of you seen doctors writing? Right? Similar to that, speech is like a cursive writing, so very difficult to understand, that is how system, that is the issue with the processing the speech. So we have to collect so many. Let us say I want to build a speech recognition. I told, right, I have collected 2000 hours of data. Probably I'm saying so you may ask, why 2000 hours of data? 2000 hours of data required because I want Andhra accent, Rayalaseema accent, Telangana accent, all region people accent to be nullified, and system should see all that. Okay, and different genders, different age groups, and covering all the vocabulary, right? Most of the vocabulary. We collected around 3,50,000 Telugu words in our database. Still lot of data is there. Still lot of words are there because we'll borrow words from other languages. The moment we go to domain, or education domain or health domain, that will have their own vocabulary. Okay. So data is the main crunch. Data is the main issue actually. Okay. After data, for speech recognition especially, what we want is a transcription. YouTube, if you go to YouTube, I have thousands of interviews, very well recorded videos are available, right? I can get data from that. But somebody has to annotate manually. If this is a sentence, this is a text, because model has to be trained, right? While training the model, we need wave file and corresponding proper transcription. Okay, those two are required. That's where the challenge actually, okay? So that is one challenge in text speech. Along with that, many other things are there actually in speech. Few other issues is that, for example, you take speech recognition, right? Speech recognition, automatic speech recognition. You are all of you are experienced, I think. You are using OK Google or voice-based accounts. Do you guess what is happening in the background? What will get recognized? I just shown my output, right? Speech recognition output. Something I just shown, right? So what is happening in the background? What is getting recognized? Speech is translated to text. So what I should model? All of you are AI engineers, right? So we know that our problem is take data, build model, build the classifier. So what are my classes here? Language is fixed, Telugu. I am doing, let us say, for example, Telugu recognition I am building. I am building Telugu recognition. Okay. Language is fixed. So what should be my classes? I should build some classes, right? Can I build words? Can I build sentences directly? Can I recognize the sentence directly? You can't, right? Why? How many sentences are there in Telugu to model? Infinite. I can't model sentences. Can I model words? I just told we have collected 3,54,000 words. So if more number of classes, more confusion, right? If I ask somebody to come and recognize 100 people, he can try to recognize. I ask, call somebody and you should recognize and all people in Kakinada. Automatically performance will be low, right? Because the more classes, the more confusion. So I can't build world level also. What we will do is only phone level. That means phone, you understand what is the meaning of phone? Phone is a basic sound production unit. Any language you take, it will be around 50-60. Depending on the richness of the language, there will be some particular sounds for every language. Okay, around 50 to 60. That is what we'll model. So we'll take the data and model the phones. The poor machine can't, so how you understand the speech? If I say something, how you are understanding? You are listening the sentence, using your brain and understanding. But the machine has to take the speech and recognize phone by phone and combine those phone to make the word, combine those words to make the sentence. That is the problem. So that's where the performance will be low, okay? Because that's where you need huge amounts of data to get trained, okay? So that is there is no other way. I can't build the word level, I can't build the sentence level. But human being has the luxury that he can listen the sentence and understand, okay? So that's where the way we want to replicate the machine with we want to replicate the brain with the machine, but the machine has its own limitations. Okay, machines have their own limitations. So they have to recognize the phones first, and from that it has to get recognized as a text. So all these challenges, one is like variations in the speech, and second one is the way we model, and also third one is lot of noise. There is no problem for noise in the text unless you write it and give. if you type it, there is no noise in the text. But if you speech, so now I am speaking, along with that, let us say some AC is running or fan is running, right? That your microphone will pick up that also. Okay, background noise is a problem, or reverberation. Sometimes these kind of closed rooms will give a reverberations. Sometimes speech itself, unwanted speech itself is a problem. Along with you, your friend is also speaking. The friend's speech is unwanted. Okay, that also disturbs the system. Okay, and your system has to be robust to all this. Okay, and another issue is that distance, right? With how much distance I should use Alexa. For example, Alexa is here. Okay, how to take care of that? Because the good part is that some are here, some are there, right? But you're still getting my speech properly, and you are able to understand. But if you put microphone here and here, the signal will be completely different. So your modeling has to handle that. Your model has to take there is one lab in in Amazon. With their goal is to collect this data only. Collect at the different levels of distance with us. Different, so that their Alexa device will be more robust. Okay. So these are the challenges. That's where data sets is a big issue. That's where you might have seen that you are all AI engineers. Most of your projects will go either in NLP or computer vision. Okay, because that data is more available now. That's where a lot of resources are. That is, a lot of human resources are there now. But slowly, a lot of attention is coming to speech also. Because if you add speech to the NLP, how many of you know machine translation? How many of you know machine translation, what it means? Machine translation means converting one text to other text. How many of you used converting Telugu text into English or something, right? All of you might have experienced, right? At least now I am using, to teach my son. I don't know much Hindi, so you want to explain me Hindi lesson, right? I have to type something in Google Hindi and get the translation output in the Telugu or English, and I am explaining. So many of you might have experienced that, right? But machine translation, how many can use? Only educated people. But if you add speech to it, that is called speech to speech. That is a national mission also. That Bhashini, the main goal of Bhashini is also speech to speech translation. Speech to speech translation. So let me show you the demo. Here also I am little fortunate because I got the first project in that actually.
We are from Speech Lab IIIT Hyderabad. Today we are going to show you a demonstration of a complete end-to-end pipeline of speech-to-speech machine translation for broadcast speeches. The main motto of this project is to convert a Mann Ki Baat audio into other language audio. So let us consider an audio file which is taken from one of the sessions of Mann Ki Baat. The audio file which we have taken is of 1 minute duration. So let's try to upload it. So in this pipeline, there are three main components. Those are ASR, machine translation, and speech synthesis. The main job of an ASR is to convert a given audio into corresponding text. Machine translation. In machine translation, it takes text as an input and tries to translate to destination language. Whereas in speech synthesis, it takes text as an input and tries to synthesize to corresponding speech. In this platform, we have integrated ASR's API from Google, Microsoft, and CDAC. For the sake of demo, we would be selecting CDAC API. In translation, we have integrated Google's Translation API and Microsoft Translation API. In TTS, we have integrated Google's TTS API, IIT Madras TTS API, and Microsoft TTS API. So in this demo, we will be selecting IIT Madras. So the source language here is Hindi, and I would like to convert Hindi audio into Telugu audio. So let's start converting.
We uploaded 1 minute of
So this platform which we have developed is also robust enough to convert 2 hours audio, but the latency involved in it is around 1 hour roughly. So we have uploaded a 1 minute audio duration file. So it would take nearly 30 seconds to complete the pipeline. So the ASR output is towards left and translated out.
basically we have given 1 minute of Hindi audio. So that first convert into text using ASR and then convert into Telugu text using machine translation, and that Telugu text is speak out for you in using TTS. This is coming.
Let's hear the TTS output.
ప్రియమైన నా దేశ ప్రజలరే, ఇది నా సంతోషం కోసం మన్ కీ బాత్ నా ద్వారా కోహిమా నుంచి కాశ్మీర్ వరకు కన్యాకుమారి వరకు దేశవ్యాప్తంగా పురులందరూ ఒక్కసారి పలకరించే అవకాశం వచ్చింది. హలో మీరందరూ.
So basically it is not perfect, but you can convert one language speech into other language. Now Indian government has a lot of interest that how to convert lot of lectures are there in English, right? That lot of NPTEL lectures, YM lectures, so how to convert them into Indian languages. So right now it is happening through everything is manually doing, everything happening manually, but can we speed up? We can't automate that, but the thing is that how far we can save the time by using this technology of speech recognition, machine translation and text to speech. Okay, that is a major work happening in the India level. Okay, because the speech recognition, machine translation, text to speech over 60 years, some level of accuracy, some good amount. That's why you are using Alexa, right? Alexa or Siri or Cortana, Microsoft Cortana, you are using that because the accuracy are more or less not 100%, but they are reasonably okay to use the systems. Any questions so far? Are you able to follow? Okay, so we'll spend some time on understanding. So I'll do this thing. The rest of the talk is like, next time when I come, I will show you the hands-on experience, any of these system like speaker recognition or emotion. Speech recognition is a little complex system which requires at least couple of days to spend and teach you. But other system like emotion or speaker recognition, we can any classification problem, we can do it. But right now what I will do is that I will tell you some introduction to speech production mechanism, which will be very interesting for you because we are the ones we are producing the speech, and then we will discuss about speech applications, how they are getting built earlier and what is happening now. Okay, so did you already started learning deep learning, or only classical machine learning is done? Okay, that's good. No. Yeah, so I will also tell you why we should learn deep learning. Okay, why we should not do also deep learning. Okay, so coming to the speech production. So who is producing the speech? We are the ones producing the speech, right? Okay, so you can see in that block diagram last two blocks, these two blocks. Okay, these two blocks are the main things, that is vocal tract system and excitation source. Okay, you can see them here also. Okay, here also. So these three blocks will happen in the brain. If somebody want to speak something, message will be formulated in the brain and language will be coded on top of it, and commands will come to your system, speech production system. So what are the two systems I am saying? Vocal tract system and excitation source. Some I will introduce few technical terms in speech. Okay, first among them is a vocal tract system, and other one is excitation source. Few other things I will introduce. So so take any language, right? What are the different kinds of, word will be formed based by combining the phones, right? Okay, so phones of that language. So if you say you are producing the language, means you are producing the phones, right? So what are the different kinds of phones, generally? Let's say you learn Telugu, right? All of you know Telugu, right? So what you learn in Telugu? Consonants and vowel. Hachulu, hallulu, right? Consonants and vowels. Do you know what is the difference between them? Why there are some are consonants, why some are vowels? Huh? Pressurize the. What is the difference between vowels and consonants? Okay. So if you basically we are all producing that, right? Now we are telling the philosophy behind that or physics behind that. So vocal tract system and excitation source. So one of them should be different. Both of them, or at least one of them, should be different for every sound. That's how different sound is coming. Otherwise same sound will come, right? Right? For example, vowels and consonants. The fundamental difference is that, so first of all, understand what is excitation and what is vocal tract. So speech will come by exciting, if the main energy will come through air, that lungs will give you the required air, that air passes through here. There is something called larynx or voice box or vocal folds. You can put your hand and feel the vibration there. These are called vocal folds. Okay, these are called vocal folds. Okay, up to here is the excitation. Excitation, the word excitation, what it means? Something is getting excited, right? Something is getting excited. Excited means some input. That input is coming through air, but not the complete air. Air is passing through this. Okay, we have vibrations. Whenever they vibrate like this, whenever they open, air will go. Again stop, go, stop. Okay, that is what happened here. Okay, so this is up to here is the excitation. After that, this oral cavity and nasal cavity are the vocal tract system. Resonators. Those are called resonators because depending on the shape of that ones, different sounds will come. We have to. This is the excitation. Excitation level. There are only two differences. One is voiced excitation. Other one is unvoiced excitation. I am introducing again two technical terms: voiced and unvoiced. What is meaning of voiced? Voiced means these vocal folds vibrate. Unvoiced means they don't vibrate. They don't vibrate. Okay. That is the only difference in excitation. But in vocal tract, different shapes we can put so that different sound will come. Now I will tell you what is the difference between vowel and consonant. The difference between vowel and consonant is that vowel means always voiced. Vowel means voiced. And also another difference is your vocal tract should be open. Can you close your can you close your mouth and speak any vowel? It has to open. Ah, whether you open widely or narrowly different, but you should open your mouth, then only vowel will come. Consonant. Consonant can be voiced or unvoiced. It can be voiced or it can be unvoiced also. But other fundamental difference is, for consonant, your vocal tract should be closed and open. Somewhere it should be closed and open. Then only that sound will come. For vowel, you should not close. For consonant, you should close at some place and then release, then sound will come. The place at which you release, that forms a different shape of vocal tract system and different sound will come. Right? How you learn the consonants? Can any of you tell how you learn the consonants? Vowels anyway, okay, you learn. But consonants, how you learn? What is the sequence? Ka? Kaka kakana or kachatatapa? What you learn? Kachata Tapa, right? So have you questioned yourself that why you learned like that? Why you learned Kachata Tapa? Why can't Pa come first, right? Now, is there any logic? Can all of you produce Kachata Tapa and feel that what is the why you should learn like that? Come again? You can see there, right? Kachata Tapa in the column wise, row wise, you can see Kaka Kakana, right? Why we learn Kachata Tapa, for example, you see Kachata Tapa we learn because if you observe the closing happening from back to front, closing happening from back to front, Kachata Tapa. Pa means the sound Pa will come if you close your lips and release only, then only that sound will come. Okay, you can feel Kachata Tapa means for Pa we are closing at lips, for Ta you are closing at teeth. Okay, similarly these are called place of articulation related to your vocal tract system. Bilabial means your lips, that Pa, Ba, like that, and dental because you are closing at the teeth. So alveolar, these may be new terms for you. Alveolar, palatal and velar, these are the places at which you close. You already can feel the lips and teeth. Other positions you may not know. Those are the names of that. That means that is the place at which you close the vocal tract system and release it. Okay. And what is the difference between Pa and Ba? You produce without voicing. That means without coming the sound comes. That is somebody pronounced like. So Pa Ba. If your sound is not there, it looks same, right? Pa Ba. So what is the difference? The difference is that one is unvoiced, other one is voiced. Okay. Ba is voiced and Pa is unvoiced. Okay. That means for Pa this vocal folds won't vibrate, and for Ba vocal folds vibrate. Okay. So similarly we have sounds called nasals, right? What is the meaning of nasals? Nasal means sound will also come along with the vocal tract. It will come through nose. So by closing your nose you can't try to produce amma. It won't come. So because the sound ma will come, only air has to pass through your nasal cavity also. So that's why you might have got cold or something. Your voice will get different because your noses will be blocked, right? Similarly, you might be saying, right? See, you might have understand like ka, cha, ta, tapa. For producing that, your tongue should play a lot of role, right? Your tongue is the main role, right? Tongue has to play a role, right? That's why you might have heard, right? If somebody in the childhood is not picking the sound, then what they will say, his tongue is thick or something, right? And put honey on top of it, So it is because it has to move. It has to move and close at some places, then only that consonants will come. Some sounds, particular sounds will pick up late in the age because they have different difficult production mechanism. Okay. Similarly, we have something called semi-vowels. Our language have that semi-vowel, something called yara, lava, right? Yara, lava. So those are semi-vowels. Why? Because, can anybody guess why they are semi-vowels? Why they are called semi-vowels? You try to produce wa. That means you are not closing or not opening. You are not closing, first of all, but not widely open. So it is in between, neither consonant nor vowel. That's why it is called semi-vowel. Okay. Similarly, we have frications called. They are typical sounds like za, za, za. Okay. Those are frications. So your excitation is slightly different. Actually, your excitation is also kind of noise. Frication will happen. Friction will happen inside. Okay. Those are the typical sounds. So you understand now speech production mechanism, because speech, many people will see speech as like any signal and process, but many people explore the speech production mechanism because it has something called vocal tract and excitation. So many times what is changing? Your vocal tract is changing, right? Your vocal tract shape is changing. So many times in the speech signal we'll suppress the excitation and highlight the vocal tract using signal processing. Or some people will say, no, don't neglect the excitation. Excitation also has a lot of information. You combine both the information. Okay, similarly, so because you see, this is how typically this is a software called Wave Surfer. If you want to note down Wave Surfer, this is a free tool. Okay, you can download Wave Surfer, which will help you to record the speech and play and do some little manipulations. Okay, so in this, you can see this is a typical speech signal. I should not have shown you the waveform. Yeah. So if you open waveform in the, so if you open Wave Surfer, it will open like this. Okay. So is it a stationary signal or non-stationary signal? Stationary or non-stationary? What is the meaning of stationary? Don't change with time. Okay, like your sinusoid or cosine or something. But this is one which is changing with time. Obviously, it depends on what you speak. Now you tell me. If somebody shown you the selected signal, only the selected signal, what is it? Stationary or non-stationary? Okay, so strictly speaking, speech is a non-stationary signal, but having said that, there is some kind of quasi-stationarity. There is within a given short segment, there is a stationarity. That stationarity is nothing but because of pitch. You have pitch cycles. Okay, you have pitch cycles. Okay. So, so the difference between this is this is the pitch period, and 1/t is the pitch. So you might have heard the term pitch, right? Pitch you already know, right? So I will show you a small interesting demo on that. Okay. So you can see typically speech has a lot of redundancy. You have seen, right? I have selected 5 frames. All that 5 frames has the same information, right? More or less. So there is a lot of redundancy in the speech signal. You want to build a AI system, right? You want to build a AI system. Let us say I want to recognize 2 people. I want to recognize 2 people. That's all the AI does, right? Artificial intelligence will do some kind of recognition or classification, etc. or regression. So I want to recognize 2 people. What I will do? I usually don't take how many legs they have, how many hands they have, or how many eyes they have, because that is a redundant information. More or less, it will be same, right? What I will take? What is their name, or what is their roll number? Our roll number is valid only inside campus. If let's say go out, maybe name may be also maybe not that enough, right? Because same name may be there. So something else, like some features which will some features which will define them. Okay, some features which will distinguish them. Similarly, in the speech signal, we have a lot of information, which all may not be required for your system to be built. So there are signal processing approaches. Which will okay, there are signal processing approaches which will extract the useful features from the speech signal. Okay, which will increase, which will improve, which will take a speech signal and extract the features. For that, mostly the time domain signal, whatever the shown signal is the time domain. The time domain signal has a lot of variation. They will go to frequency domain. There is a signal processing approach called Fourier transform, but they don't apply Fourier transform for the entire signal. I shown some frames, right, where there is some kind of stationarity. So they will take small frame by frame and extract features. That is one of the classical approach. All this speech recognition, before doing the phone recognition or any recognition, they will extract these features. The way I am extracting some features to identify the people, we have to extract some features from the speech. That is what classically people will do. That is, there is an algorithm here which is called, you might anytime if you want to work in speech, the first feature you will heard is the MFCC, male frequency capsular quotients. Male frequency capsular quotient. There is a signal processing algorithm to extract that. I can spend some time on it and explain, but because of deep learning, this became obsolete. Even still you can use for doing some projects etc. and understand MFCC, but there are a lot of tools to extract MFCC freely. In Python you have a toolbox called Librosa. The Librosa package will give you this MFCC feature, but that is not the state of the art. That state of the art means what is currently people are using. That is called spectrogram. Okay. Have you gone through computer vision or image processing is done? No. Done? Image processing is done, huh? Okay. Going on. Have you heard about CNN? What is that? CNN in deep learning. Deep learning is not done, right? Okay. That's okay, no problem. So in computer, so what is happening is that, as I said, computer vision research are more across the world. Okay. Then NLP, then speech. So because of that, what happened? Most of the developments will come in the computer vision. Then that influence will come to these areas also. So there is a popular architecture called CNN, that is convolution neural network, which is very famous for processing the images. Okay. So what now the hangover happened is that now speech also they are converting into image. Speech is a one dimension signal, right? Time versus amplitude. Now I am converting, you can see here. Okay, this is something called spectrogram. That is called, what is it called? Spectrogram. We will apply something called short-term Fourier transform and get this one. X-axis is time. Y-axis is frequency. X-axis is time, Y-axis is frequency and the amplitude. That means at what time, what frequency is there we are plotting. From the speech signal, we will apply short-term Fourier transform. That means every small frame you apply Fourier transform, get the frequency information. So time versus frequency. Now it became like image. This they are feeding it to CNN networks. Okay, that is so now this is the things are happening actually. Outcome is what you model. Whether if you are modeling speaker recognition, outcome will be speaker ID. If you are modeling language identification, output will be language. If you are building, that depends on what you model. Okay. And similarly, I have to emphasize one point here, that how many of you heard about sampling? Sampling in the signal processing. So speech is analog signal or digital signal? Analog, right? I am live analog signal. But I can't represent analog signal. You might be seeing this signal, right? Speech signal. It may look like continuous signal, but that is not the continuous signal actually. Okay, that is a that is a digital signal which I am representing like analog signal on computer. Analog is system is a digital device, right? So that analog signal we can't represent on computer. We have to digitize it. For that there are two important things. One is sampling and other one is quantization. That problems are not there in NLP. Okay, the text processing don't have, the text has no issues of the sampling and quantization. Okay, but speech has that. Most of the audible frequencies will be in what range? Audible frequencies will be around 300 Hz to 3400, something like that. But fricatives will be around 5K or 6K also. But they are very less frequent. That's why 0 to 4. That means 4 kHz. 4 kHz is what usually enough to understand the speech. Okay, the frequencies between 0 to 4 are good enough for understanding the speech. So there is a sampling theorem is there. What it says is that if you want to preserve 0 to 4 kHz, minimum sampling is required 2 times of that. If you take 2 times of 4, that is 8. Minimum 8 if you take. Anything more than 8 is luxury. Anything more than 8 is luxury. That is good enough. I can tell you this concept very easily with this example. How many of you downloaded the song from internet? Nowadays not required. Ghana app is there. You can listen from there. Spot. But some of you might be downloaded the songs, right? Have you seen 128 kbps, 320 kbps? What is that 128? Have you observed that compared to 128 kbps, 320 kbps song quality is good? Memory also more, quality is also good. And you might even now lot of quality has come, right? 4K quality, or or this 1000 to 4 kbps, very high quality audio is coming, right? So all that, how you come up that 128 kbps? Okay, that how it comes is that, let us say speech up to 4 kHz is enough. Maybe for songs and all, maybe 16 kHz may be required, because 8 kHz, up to 8 kHz may be required. So sampling frequency will be 16 kHz. That means per second I am getting 16,000 samples, and every sample is again analog. You have waveform and you are sampling. Sampling means you are making it discrete. That every sample you have to digitize, because it's a computer understand only 0 and 1s. So for that we will do something called quantization. So we'll use for everything, maybe represent using 8 bits. So multiply 16 into 8. What is that? How much is that? 16 into 8. 128. Right? So that's how that 128 kbps will come. Let us say if you preserve more. Usually for speech we require 8 kHz and 8 bits. That means 8 kHz sampling rate and 8 bits. So bit rate will be 64 kbps. 64 kbps. Okay, that is that. So why we have to remember this, understand this sampling, is that whenever you build a system, while training and testing, the sampling should be same. If you are building at 8 kHz, you should not test with 16 kHz signal. Okay, you should also test with the same. So whenever you are building a speech system, make sure that the system you build and the system, the input you are giving with, will have the same sampling frequency. Okay. So now I think some of you are feeling sleepy. Let me show you one demo. Okay. So we heard about pitch, right? What is a pitch? Pitch is nothing but, you have here in the excitation of speech, there is something called vocal fold vibration. Vocal fold vibration, right? This is called vocal fold vibration. So this vocal fold vibration, usually compared to male, it is more for female. Compared to male, female pitch is more. Compared to female, children pitch is more. Okay. So have you heard about talking tom application? What is happening? Any idea what is happening there? Huh? It is nothing but they are converting your pitch. You observe that app works very well if male speaks. Female speaks okay, but children speaks that it will be more, it is not understandable actually. Usually children's speech is difficult to understand, but if you give it to talking tom, it will be further difficult actually. So I will show you talking tom. This is the actual speech. I think
మీకోసం చాలా సేపటి నుంచి చూస్తున్నాము. మీకోసం చాలా సేపటి నుంచి చూస్తున్నాము.
Is it audible? Okay. So it is what voice? Can I make it male voice? How to do that? Decrease the pitch. But what happens if I can do that in the time domain? But what happens is that if I do the pitch, that means it will be it will become like a dragged version of it.
మీకోసం చాలా సేపటి నుంచి చూస్తున్నాము.
Okay, this is anyway, this is maybe new to you. This is the talking tom. Have you heard about talking tom, this one? Okay. So I can make it further also. Okay, so I am sampling in the time domain. What is happening? Because of that, your pitch is changing. Your pitch is changing and becoming like a male voice. Female become male, or female become more childish kind of. There is nothing like cat. Cat can't speak, right? Similarly, this is the one demo. You observe it.
మీకోసం చాలా సేపటి నుంచి చూస్తున్నాము.
There are two things playing. Okay. So this is the normal speech.
మీకోసం చాలాసేపటి నుంచి చూస్తున్నాము.
So you observe that we done some manipulation, but it should look like a same speaker speaking in anger emotion.
మీకోసం చాలాసేపటి నుంచి చూస్తున్నాము.
Are you feeling that? No. Speaker is same.
మీకోసం చాలాసేపటి నుంచి చూస్తున్నాము.
Normal sentence.
మీకోసం చాలాసేపటి నుంచి చూస్తున్నాము.
And it looks like same speaker. So there also we done some manipulation. Whenever you are anger, right? Whenever you are anger, your speech will become faster. Your speech will become faster. If you observe talking Tom, it is doing fastly only, right? It become faster, but it changes the speaker. Speaker should not, speaker should not change. I should want that female only speaking like anger. Okay, so how to do that? And similarly, I want to increase the pitch. Whenever you are anger, your pitch will increase. So we have done this manipulation with something like, it's more like signal processing side. There is something called phase vocoder. That is nothing but it will do the resampling. Earlier one, the talking Tom one, you are doing sampling in the time domain. Just you are discarding some samples or adding some samples. That's it. That is the earlier one. But if to do this anger, neutral to anger emotion, what we did is that we will do this manipulation of duration, etc. in frequency domain. We will replicate the frames or discard the frames, so that I have shown the frames, right, where some kind of similarity is there, right? If I want to increase the, in layman terms you can understand that you want to increase the duration, what I will do, I will increase the cycles. If I want to decrease the duration, I will discard the cycle. I will discard one cycle. So your pitch is preserved. Okay, you are not doing at the sample level, you are doing at the frame level. Okay, higher level. Okay, that's how your pitch will be preserved. So anyway, you might have this kind of manipulation, and still you can use AI also. Why I'm telling this application? Let us say, how many of you seen the railway announcements? Like railway announcements, very monotonous, right? That is the text to speech technology. Please, that is the text to speech technology, right? Similarly, where else you have seen text to speech? Where else you have seen text to speech? Google Maps. I want to come from Kakinada to your college. I can put Google Map and come. It will help me to drive, right? Okay. So, but let us say I want to use the technology to tell story to my kids. Like railway announcement or a Google announcement. If you tell a story, you can't tell story like that, right? You have to have emotions inside it. You have to add emotions to it. So that's where this kind of this technology, text to speech with emotions, is what people are working now. Okay, so any questions so far? Any questions? So yeah, so we have seen some speech basics. Okay, similarly we have seen how to represent speech in the form of features. Means there are classical features like MFCC, but people are nowadays using spectrogram. I have shown the spectrogram, right, using wave surfer. Okay, now we will go to AI side. Okay, with this speech background, we have to go to AI. Let us say I want to build speaker recognition, or I want to build speaker recognition means identifying the speaker from the speech, or language recognition, or speech recognition. So how to do that? So for our understanding, I just divided this application into two broad categories. One is simple classification problems like speaker recognition, emotion recognition, language recognition. These are simple classification problem. That means take input, just like your flower classification or text classification, right? These are classification problems. Nothing to do with, take data and, based on the class data. Let us say I'm building all speakers data. So I will take data from each speaker and build model for them. Okay, they are simple classification problem. But these two, like speech recognition and text to speech, are not simple classification problems, right? It is not classifying the language or classifying the speaker. It is we are going from one domain to other domain. You are going from speech domain to text domain. So what is important here is that in this speech to text domain, or these kind of problems, these are called sequence to sequence mapping problems. These problems are not simple classification problems. These problems are called sequence to sequence mapping problem. I have to map this phone sequence into text sequence. Okay, so their modeling is slightly different. How many of you heard Gaussian mixture models? Support vector machines. This classical machine learning is covered or not? Okay. So how many of you heard about hidden Markov model? Hidden Markov model, have you heard? No, not yet. Okay, that's fine. So anyway, I will go in the layman terms only. So the thing is that if you want to do simple classification, you can use random forest or XGBoost or Navibase or Gaussian mixture model or support vector machine or even neural network model. Simple neural network model you can use. They all can do simple classification. But this below ones, all models can't do the task of sequence to sequence mapping. Only two models are very popular. One is classically hidden Markov model. Over the years, last 30-40 years, hidden Markov model is famous for that. But now neural network has come, right? As neural network has come, it became more popular. In that neural network, there is something called recurrent neural network. Have you heard about that? Recurrent neural network. That is the architecture which has the capability of sequence to sequence mapping. What happened is that last 30 years, all these problems, some kind of models and way of building is done. Once deep learning comes, everything changed. It's a game changer, right? All of you joined in this, or your chairman is wise enough to remove all branches and to start AI branches because of deep learning. Inherently, the driving force is the deep learning, right? Let me show you one slide and explain. I think some of you might have seen already this one, but let me show you that. How many of you think that AI is new? Can you please raise your hands? How many of you think that AI is new field? Huh? Is AI new? AI is not new. AI is there from long. Okay. Some of the algorithms are as old as 80 years. Okay, but why AI has come now? Why AI branch has come now? Okay, but anyway, there are even some of our branch names are even my title in the today talk, right? AI and ML in speech. That is the wrong title actually. Why? Because if you are ML is a part of AI. If you want to use only one term, that is AI. Okay, ML, deep learning is all part of this term AI. Okay, so that means whatever way you create the artificial intelligence, that is AI. If you use some set of statistical techniques, that is called machine learning. If you use in that deep neural network, that is deep learning. Deep learning is in fact is a part of machine learning. Okay. So this is about, anyway, it's not about COVID wave. It is about neural network waves. Okay. So somebody will call it as a second wave, but if you closely observe the neural networks, it's a kind of third wave. Why? Because in 1950s, this neural network got introduced. Okay, means the concept of neural networks, etc., inspired by the human brain, right? Human neurons. And then in late 90s, a lot of work has happened in the neural network. Okay. In fact, there is a neural network book by Professor Agnarana. Okay, he is a retired IIT Madras prof, and he also worked with IIIT Hyderabad. He is also my guide actually, my supervisor, PhD supervisor. So why I am telling that is he guided around 10 PhDs in 90s itself on neural networks. My guide PhD is in neural networks. Okay, he proposed neural network for prosody modification. Whatever I told, right? This prosody prediction actually for text to speech. So he has done that in late 90s or early 2000s itself. Okay, so neural network is not new, but now why this wave is very strong and why this is game changer? It's a big game changer. Your college is an example, right? All branches are replaced with this one. It is because of this game changer technology, deep learning. Why? Because that graph will tell you everything. That graph will tell you everything. So so far AI is there, but can you see the red line? It is not very visible. Can you see? Yeah, the red line is one which is people are hanging in the red line over last 50-60 years. Okay, that red line is not a game changer because it if accuracies are around 60-70, I can't build a Alexa, I can't build automatic technology. But see the blue one is the game changer. Okay, the blue one performance is more. Blue one performance is, you can see that more. Nothing is perfect, even human is not perfect, right? So we also give, if you give 100 works, you will do only 90 works properly, if you are very efficient, by the way, right? So if you reach around 90%, you can build a system, you can build a automation, you can go for automation, right? So the blue is a game changer. Blue line is the game changer actually. That blue line is because of deep learning. That red line is because of classical machine learning. So you should learn both, that's fine, but everywhere you may need not require deep learning. But so now the question is that, I will tell you is that, anyway, this will be motivation for all of you because most of these technologies you might have not yet studied. Okay, but so I can see some of the applications I written. Somebody can read for me. What are the applications I wrote there? Which we are already discussing: speech recognition, image classification, natural language processing, chatbot. Okay. So tomorrow you are going to develop one of these applications. That's how you survive, right? You have to go to industry and go and build these applications, right? You have to build a fault tolerant system or automation system or some kind of classifier and all that, right? That is the major role of AI engineers, right? So now earlier for every problem, for example, you take speech recognition. I have something called hidden Markov model, okay, which is famous. If I go to image classification, I will use support vector machine. You may learn them very soon. Okay, this hidden Markov model, support vector machine, etc. They are very new. Sorry, very old. Okay, so what I'm trying to say, for every application has some demand. Every application, let us say I want sequence to sequence mapping. One way I want simple classification. According to my problem, I take a relevant statistical model. But deep learning come and say, go, all models bye and use me only. So you should ask yourself, right, how should it happen like that? So speech recognition is a different problem. Image classification is a different problem. How can you say that one approach will solve all the problems, right? Are you understanding why I asked you to read that? Is every application is different. Not only the data, the way of application demand also different. But still we are saying for all application use deep learning. Why? Because the beauty of deep learning is follows. The curve, the game changer is because of following, right? Because 4 reasons. One is, 2 is non-technical, 2 is technical. One is that nowadays amount of data is more. When we studying BTech, the person who has floppy is great. How much is the floppy size? Anybody knows? 1.3 MB. We have a floppy. Okay, we have a floppy which is of size 1.3 MB. Okay, and how much amount of data you can store there? Very small, 1 or 2 word files, 2-3 word files, your memory is gone. But now your mobile is more powerful than 10 years back systems, right? So the amount of data increased, the amount of memory increased, so the amount of data increased. That is one advantage. Other advantage is that, how many of you heard GPUs or multi-core CPUs? So recently they have come that, last 10 years that GPU, CPUs have come. So those will give you the required computation power. You have more data and more computation power. Fine. That is there for every model, right? That why red has the red also has the more data. Classical models also has the more data, more computation power, but they are saturating. Okay. The third reason for deep learning popularity is that name itself is deep learning, right? Deep. That means if you have more data, take more parameters. You have more data, take more parameters. But other classical models don't have that many parameters. I am telling in layman terms because many of you are not experienced with the AI and this kind of techniques so far. So I can't explain in short time all these things. So the thing is that any classical model you take, hidden Markov model, support vector machine, any of these model you take, the problem with them is the amount of parameters you have to optimize are limited. The amount of parameters are limited. Okay. On the other hand, deep learning has many parameters. You can take more parameters if you have more data. That is the one advantage. The last and powerful advantage is that none of these models have the concept of architecture. No, their modeling is fixed. But in neural networks means what? These neurons, okay? These neurons connecting each other, okay? So the architecture means the way you connect the neurons. The way you connect the neurons is called architecture. So one architecture may not solve all the problems. The beauty is that depending on the problem, will come up with the architecture. Last 10 years of AI research, if you see, especially last 5 years, revolving around this name called architecture. So people will come up with the architecture which suits the problem. Okay, let us say recurrent neural network. I just said recurrent neural networks. People didn't thought 5 years, 10 years back that hidden Markov model will go off. Hidden Markov model will gone off because of RNN. Because RNN has the sequence to sequencing mapping capability. Your problem wants sequence to sequence, that can be provided by recurrent neural network architecture, not other architecture. So the neural network beauty is, please remember whenever before reading the neural networks or when if you get that subject, the beauty of neural network is the architecture. So it has different architectures, recurrent neural networks, LSTMs, convolution neural network, what you just said, convolution neural network, and encoded decoder architectures, and DNN with attention architecture, LSTM with attention architecture. There are so many architectures. So some architecture will solve some problems. Okay, not all architectures will be solved all problems. So depending on your problem, you will apply architecture. So that's how, whatever may be the application, you are telling deep learning because we have something called architecture. Okay, so anyway, you will understand these when you introduce neural network. Just I want to show you the number. So any classical model will take maximum some 3-4 parameters only will be there to vary. But if you take neural networks, all these parameters will be there. Number of layers, number of neurons. What is deep neural network? Deep neural network is nothing but if you have more number of layers and more neurons, that is deep neural network. Otherwise, simple neural network. And similarly, number of epochs, activation function, loss function, batch size, learning rate, kernel. So many parameters are in your hand to vary. Okay, that is also called hyperparameter tuning. Okay, so that is the beauty of neural networks. So, but what is the problem with the neural networks is that you also should know the downfall, right? You should also see. So first of all, yeah, most of the time state of the art is neural network, but we should not blindly apply for all problems neural network, because some problems may not neural network. Some problem may be simpler. Then you learn whatever classic ML you learn, you should apply. For every problem, if you use deep learning, the problem is the pollution, right? If you run one deep learning program, lot of GPUs will run in the background. That GPUs will generate lot of radiation. To run the GPUs and etc., you need a lot of electricity. So very soon there is a revolution on green AI will come. Green AI means you should not blindly build the models, the way you want. And second problem with the neural network is the explainability. I have so many parameters, so I don't know how I get the decision. I may get the decision, but I don't know why I'm getting the decision. So explainability will be the big issue. There are a lot of success stories for AI, but there are also failure stories for AI. Big failure stories. You know that there are some flights crash, some model of Boeing has some issue, right? Software automation issue, right? Malaysian Airways, couple of aircrafts crashed. You remember? You heard that it's a software problem because pilot is asking to go up. That automation is showing you have to go down. There is a conflict, and system is not taking the command of pilot. Crashed, and they went and updated the software. So to get the critical approvals of this AI systems is not this. Let us say I want to use this AI system in defense to detect the target. Okay, I use deep learning model and I recognize the target, and target says, and if you find the target, you will bomb it, right? So what if it is our own vehicle? How you authentically say, how model is saying it is the target vehicle? If that explainability is not there, then model won't be passed to use in the field. Similarly, in the health space, the model has to explain why it is taking the decision. There will be human in the loop, and model also give some hints that these are the reasons why I am able to say that this is the target. If it is not able to say, then it is that models are that critically we don't. We can use the application like speech recognition. Few non-critical application you can use, but for critical applications, unless the explainability requirement is passed, it won't be used. Okay. This AI and automation has a first failure story in US also. Okay. How many nuclear plants are there in US? Anybody have any idea? How many nuclear plants are there in US? Huh? Can you Google it and say? 0. They have 0 because they have failed in automation. They have they have this plant, but that is about to burst and somehow they stopped it. Then the country decided that they American sponsored one they will put in other country by force, but in their own country they don't put any nuclear plant. They will get nuclear energy from other poor countries. They will put their plant there and get that what they want. Within that, because they know the if that automation fails, they know the loss. Okay. So similarly, this kind of automation has its it's not that everywhere we should use deep learning and everywhere you should automation. We should know where to use, where not to use also. Okay. Yeah, I think it's a one-way communication happening. So I want to listen from you now. I want to stop here because for the next time when I come or when you come to us, we'll discuss further in speech. Apart from that, the main purpose of this lecture is that I just want to introduce speech field to you because many of you may not know what is speech and applications. I just focused on that. Okay. And given some applications and the need for speech. Okay. Coming to just let me talk few minutes about my lab. We have in IIIT, ours is a unique institute because we don't have any departments. We don't have any departments like ECCS departments. We do offer BTech in EC and CSE, but we have all research centers. Okay. I comes from LTRC, Language Technology Research Center. So we all work in the problems related to language. So we have around 9 faculty. Some of them are computer science. I am from ECE, right? There are 4 faculty from linguistic background. Linguists. They are not from EC or CSE. They are pure linguists. Okay. So why we all working together? Because our problems demand these fields. Okay. Similarly, we have some centers which have multiple discipline faculty because our interest is to solve the research, solve the problem through our research. Okay. So we have different research centers which collectively offer BTech in EC and CSE, but otherwise our focus is on research. So and again another actually this IIIT name especially in Andhra, got little disturbed once this IIIT is adopted by other AP IIITs, right? But they are not IIITs, okay? They are Rajiv Gandhi Institute of Knowledge Technologies. Okay, on paper they are not IIITs, they are RGKT, okay, Rajiv Gandhi University of Knowledge Technologies. Ours is IIIT, which is actually now current is the 25th year for us. 1998 we started. Now 24 completed and 25th year started. We have a year long different celebrations. So why our institute is unique is that ours is a kind of US model non-profit institute. Okay, there is no owner for IIIT. Neither government is owner nor private is a owner. Okay, and there is no funders also for us. There is no funders. So it has to the model is that you have to generate the money by yourself through your BTech fees or projects or whatever. All running expenses should come from you. Institute has to generate. Okay, then when we start our model, we know that along with the teaching, research should be there to excel, to be unique. But again, to do research, we need students, right? We need students to do research. So then we have MS and PhD, but what initially we thought is that why can't we use our own BTech students for research? So undergrad research is the one of the unique in IIIT across the India. Even because the way our research focus will be given to our UG students is not there in any other institutes. Because I can authentically say, because I studied in NIT, I studied in IIT, I visited few institutes there. There is nothing like research component in the undergrad. Okay, so so how we have done that is that we have an inverted curriculum. What it means is that all core courses will be completed by second year. And we have only 9 core courses. We will complete all of them in first 2 years. First year itself we will start microprocessors, digital logic, all whatever main courses will come within 2 years. Within 2 years your core is done. From third year you are ready for if your goal is only job, you are ready from the third year itself. Why we done that? Some like our model is like practice, theory, practice. Practice, theory, practice. Some of the modules you may not know, but you will do it in first 2 years. If you will go further deeper into that in third and fourth year, based on electives what you choose and go into the particular area. Okay, so by the time of end of second year, they are eligible to take honors projects or research projects with us. So that, and also we have something called dual degree program. Dual degree program, that is BTech plus MS, not MTech. BTech plus MS. So from second year end of second year, they will start working with the lab. Third and fourth year also they will work along with the courses, and fifth year is only thesis. Okay, so they will get 2 degrees in 5 or 5.5 years, because their time is not fixed, because they have to produce the research, they have to produce the paper and thesis out of it. Okay, so that's how the advantage is that what we will do in dual degree is that, so from third year they will start working for the lab. Okay, and in the fifth year only they will do research. Okay, so fifth year also what we will do, as they are already working from third and fourth year with us, fourth year will pay their fee. They don't pay their fee in the fifth year. Fifth year student fee will come from the faculty, because we will generate the fund from our projects, etc. And even we will give fellowship in the fifth year. Some 10,000 rupees we will give to the students for their running expenses. So that's almost like fifth year is free for them, provided, because they are already putting some effort for executing our projects in third and fourth year. Okay, similarly we have MS program, which is like you people BTech outside, and you can come and do masters with us. Our masters fees is some X amount, but don't worry, you no need to pay anything, because some fee details may be there in the website, because that is we have to pay. Okay, MS is free of cost, PhD anyway free of cost. Okay? In fact, you will get fellowship also. And we also have another program called standing committee. Our MS actually, our MS and PhD admissions, our entry is easy. Anyway, exit criteria is same. Okay, so why entry is easy? I can recommend we have a standing committee. Of course, there is a committee to validate that, but I can recommend directly. Let's say some few of you candidates are liked by me, and you also like to work with us. I can directly recommend for your admission. Institute also will say mostly yes if your resume is okay. Why will they say yes? Because your fee I have to pay. Okay, I am paying means I should get something out of you. I am confident that I will get something out of, then only I will pay, right? So if you work 3 months, 3 months is the minimum criteria. If you work 3 months and mutual interest is there, if you apply for the admission, I can directly recommend, or any faculty can directly recommend, and standing committee can give the admission. Okay, that's why I'm saying entry is easy. But exit anyway, you have to publish paper in a quality A type conference and exit. Okay, so that flexibility we have. Ours is initially started as Indian Institute of Information Technology, IIIT, Indian Institute of Information Technology. Then after few years, government said you come to government. That is getting a lot of popularity that time. Then government says you come to government, we'll take care of everything. Is what they said. No, we told we don't want to come because we lose the autonomy. We don't want to come. Then they said you should not use Indian. If you are not government supported, you should not use Indian. That's why we want to keep that acronym. So we replaced Indian with International Institute of Information Technology. Otherwise, initial name of few years is Indian Institute of Information Technology only. But right now it is International Institute of Information Technology. It is the only institute in India which is self-financed from day one. There is no initial fund. But of course, the government has given lands and buildings. But anyway, after that we registered with our name, IIIT Foundation name. Okay, unique institute and next generation institute. I can say we have a lot of freedom for the faculty and the students. There is only merit. There is no other criteria for admission. Only merit across the India. IIT JEE admission. Only merit. No other criteria. No other admissions. No. We can sell our IIIT seat for 10 lakhs easily. 20 lakhs also easily. There is nothing like that. Okay, and also we have from last couple of years we started encouraging because of our fees is slightly higher, not like around 3 lakhs or something. I didn't remember exactly, but because of that or something, there is a lot of lot of, we are not expecting the diversity what we want. Well-off family students only. Of course, they have to pass the IIT JEE and come. So to encourage the lower pyramid, we started a few admissions like we are giving a special admission for RGKD students. So RGKD students, after 2 years spending there, if they write our exam and pass, they can come BTech to us. Okay, we are calling it as special admissions, spec admissions. We are recruiting around 10 to 20 students like that, and for them we are giving a support from day one. So they don't need to pay anything. Okay. But somebody else paying for them. So we raise the funding from outside. This model also may help your institute. So what we are doing is that we have two things. One is like either alumni or somebody will support them. Some company or somebody will support them for 4 years. And what they have to do, once they get the job, they have to repay. They repay how? That year fee of one student. Like you, somebody else will join. That student fee he has to pay. Okay, like that. That is a sustained model. Once if somehow we manage 20 students, then that thing will continue forever, because that 20 will support other 20, that 20 will support other 20, like that. So that's what happening. So any low privilege students also should not feel disadvantaged that this much fee I can't pay. Another thing is we have specially to attract the girl students. We have earlier only 5%. That means out of 100 only 5 are girls there. Now our target is to increase at least 25 or something like that. So for that, what we have done, even though it is a big decision as it's a self-finance institute, still what we have done is for girls 25% fees considered. Last 2 years back they have taken a dare step that some set of not all girls, from some 20 that pool has 20-25 seats. The 25 seats, the fees is only 75%. 25% is waived off. Okay, so with that, girls admission also there. Otherwise, there is no, even girls also, they have to get the required JEE score, then only they will get the admission. There is no special consideration for them actually. So far so good. Institute is moving fine. Our challenge is to raise the fund and do high quality research. So we are yeah, that's how system is. So I'll say two things and close. So two things. One, what we are different is our curriculum is inverted. As I said, what you study in what you usually will do is that by the end of 4th year you will ready for the project, or 3rd year you will ready the project. by the time your placement or something will come, you will, you don't much contribute to the thing institute. But if you are ready by second year, you can do something quality project, etc. in your third and fourth year before you go to the placements, right? So that is the one thing we have done. And anyway, that worked well for computer science background, because some of the like mechanical engineering or civil engineering, that model may not work. But for computer science, that inverted curriculum worked well. Okay. And second thing is, our institute from day one started on picking the good people. We don't have any fund. We brought the good people, they raised the fund, and they build the institute. Many times what happens, you build the infrastructure and bring the people. Ours is reverse. We don't have much infrastructure. We bring the quality people, people will bring the infrastructure. So last 3 years back, TCS has generously given 20 crores for us. With that name, we have started a center called Kohli Center for Intelligent Systems. You know who is Kohli? Not a Virat Kohli. Kohli recently passed away. He is 90 plus. He recently passed away. We saw him 2 times. Kohli is the first CEO of, he also known as father of software for India. He is the first CEO of TCS. On his name, we got 20 crores. And still they are giving some funding every year, some 5 crores or something, or 2 crores or something they are giving for funding our research. Okay. So any of you are, any opportunity comes anyway. Madam is actively, and Ravikant sir and others are actively engaging with our institute. So any of you get an opportunity and you excited, we don't say, for our own students also, we won't say you work in this area, you work in that area. We don't say like that. You explore different areas and choose your guide, or choose your area, choose your lab. And similarly, whenever you get an opportunity to expose to different faculty of IIIT, so try to see that, and if your interest matches, try to approach them and try to work with them even remotely, or come to campus, right? And if you are interested, you can convert your internship into a master's degree or PhD. We even take PhD after BTech. There are some couple of students joined with me last year. In fact, this year, they both are BTech graduates. They may need to do more coursework, that's okay, but they can do PhD. Okay. And how many want to do higher studies? Okay. Yeah. Try to, it's not that, if your goal is only money or job or something, that's fine, you go. Otherwise, higher studies is required nowadays, because you will be more expertized. And also, when you do higher studies, you choose the area, you spend some time, or if you are not, your family is not able to support, you work for a couple of years and then also you can do, that's okay. But you work with passion and you try to choose with the passion. Okay, don't blindly go. Somebody is going to US, I am going to US, or somebody going somewhere, I am going. You don't know what you will do after going there. See, you choose the area, or you choose some faculty, or you choose the domain, and accordingly do the groundwork. Nothing wrong in it. You can approach anybody in India or across the world. The people with whom you want to work, you should approach. You show your interest.